Hi, this is Subramaniam Shankaran. So the seventh video in the series with respect to the Google Secure AI framework. It's a denial of machine learning service. Okay, so there are now this is on the availability part of it, and there is also an attack. Okay, though it's a denial of mission service, sounds like a DOS attack. There is also an integrity portion towards this particular attack. Okay, so denial of mission service attacks when adversary intentionally overload the AI system with excessive computation intensive queries to disturb the normal functioning. Now, the people who have joined me for certified security penetration tester, there's a command called HPing3 or LOIC is what usually we follow for the DDoS attack. Okay, you fine tune it with the TCP, UDP, number of packets per second. So it attacks the target, that with that many packets. So the target, if not able to withstand that volume, it actually goes down. So normally on the DDoS on the network, this is what we actually do. But this AI is going to be on the application layer. Okay, now we have an API. Okay, and the interface we have is the web interface. Now, if you want to take the application down, we need to submit the query onto the web interface, so directly onto the AI application, so that the computational power is going to increase and it's actually going to go down. Okay, that's what is actually the problem. Okay, let's look at the various attacks. Volume based attacks, amount of query that you're actually putting in. Okay, the compute based attack, it's a single query, but the amount of computation it has to do actually. Okay, it's called compute based attack. The exploitation of model vulnerabilities. Obviously, if there are vulnerabilities, then it'll target that vulnerabilities to take the system down. Okay, that's not only with specific to AI, but for any application, that's what it is. I'll try to find out the vulnerability. Model scan is one of the tools by which you can find the vulnerability on your model, and then we can take it down. Increased operational cost. Okay, I'm going to more and more utilization that you're going to have, especially if it's going to be on a cloud where it's pay as you go. Okay, the metered service. Okay, so if the computational cost is going to increase, okay, then you say there's no point in running this particular application on the cloud. Okay, so you'll shut down the application. That also leads to an availability attack. Okay, indirectly. So volume based. Okay, too much of a request. Compute based, one request which consumes a lot. Exploitation of model vulnerability and increased operation cost. Okay. Now a sponge attack. Okay, now what's a sponge? It could be very small when you look into it, but the moment it starts observing the water, okay, the size of the sponge is going to increase. So the sponge attack basically is it is going to be a single command, but the amount of computation that the model has to do to execute a response, okay, come back with the response to this command is going to be immense. Okay, attacker crafts a specific input that is designed to maximize the energy consumption and computation time of the model. So this is called the sponge attack. Complex models, blah blah blah. It actually does it. Normal customer goes to the barista. Okay, barista or cafe coffee day. Okay, Cafe Costa, Cafe Ritaza, okay, Starbucks, whatever it is, Wayne's coffee, the most beautiful, wonderful coffee. Okay, I used to enjoy it when I was in Sweden, Kista Mall. Okay, now giving that thing aside, the customer goes to the shop. Okay, I ask for an cappuccino strong with the hazelnut syrup in it. Okay, that's what something which I like. There are people who can purposefully give an the instruction like this. Okay, if you look at the slide, half cup and then triple shot soy milk latte heated to exactly 182 degrees, stirred counterclockwise 14 times the foam shape like an swan, but swan has to be looking left. All this instruction, it takes a lot of time for the the employee to the coffee shop staff to prepare this coffee. So a sponge attack is a single instruction which is going to consume excessive energy. Okay, now the excessive utilization, okay, and all these things are a part of the OWASP vulnerabilities as well. Your OWASP has got ML vulnerability, NHA vulnerability, and the LLM vulnerability. Okay, excessive energy consumption, okay, or the excessive utilization. Okay, we have got similar attacks. Then we're going to have a series on those things also. Okay, now if the LLM is going to receive a command or the AI application is going to receive a command like this, it takes a lot of time for it to process it. It's called a sponge attack. One command, excessive utilization. Okay, so this basically means that the latency will go down. Okay, the response time for other responses will actually go down. It takes a lot of time to come back. Energy utilization is going to be high, And if the computational power is also going to be high, it's definitely going to impact your monthly billing if you're going to have a cloud-based, if you're going to host it on a cloud-based platform. So, okay. Now, what is the remedy? 2 minutes rule. Okay, so if the manager sets a strict rule, if any drinks taker takes longer than 2 minutes, let's not do it. So, if you're going to accept the input, if you feel that it's going to take a lot of time, the system will not accept it. The next one, menu check. Now, I cannot say, swan fees, stir it 14 times. The swan should be looking left, or it should be on soy milk. No. If that is not there on the menu, okay, then you will not accept it. That means that the instructions that is read by the large language model should be the preset instructions. Otherwise, no. Stress test, okay. So again, availability stress test is something which is not very unique to the AI application, but it is every application, especially web-based application. There are tools using which you'll be doing a stress testing. Okay, you'll be using fuzzing. Okay, to ensure that what is the amount of requests it can actually entertain. So that's actually called a stress test. So during the training, we intentionally send nightmare customer. Okay, so the training phase. Okay, we bring in a model to handle all the situation, but sometimes we'll ignore it. It's not that is not my cup of coffee, right? So I can do what is available with me. If something you order, it's not available, just say no. Okay, similarly, the LLM application, you just do what is required. If anything, a sophisticated input comes, you can just ignore it. Okay, there's also the API secure AI gateway. Okay, you can ignore it right there. Okay, like how you handle the prompt engineering. Okay, or prompt injection. Sorry. Algorithmic complexity. Okay, attacker sends input that exploits a specific mathematical operational algorithm. How does it actually work? Okay, there are 100 hooks on the wall. There are 100 customers coming in, and you will hang the quote, okay, for every customer on 100 different hooks. Now, if you're going to change the algorithm in such a way that, okay, the quotes are hanged, okay, on the same hook for all 100 customer, okay, and if there's a customer requesting his quote back, okay, you need to dig deeper, okay, to get that particular quote, okay. Now, the concept for the algorithmic complexity is same. I'm going to change the algorithm, okay, in such a way that, okay, when there is a response, okay, it takes a lot of time for you to get the response out. Okay? That's called the algorithmic computation. Complexity attack. Okay. Difference or find adversarial reprogramming. This is the most beautiful attack. Okay. Now, the application is actually developed for a particular purpose, but I'm going to misuse it. Okay. Now, the scenario given in this presentation is if I'm going to have, let's say, an application which is going to look at a selfie, upload a selfie, it can do an emotional detection and tell you whether he is happy or not. Okay? But now what I'm going to do is, surrounding that image that I'm going to upload to the website, I'm going to have something like QR code, okay, and mask, okay, that's going to read about the credit card, okay. Now the credit card is valid, okay, that means it'll show and it'll give me a response saying the customer is happy. The credit card is not valid, then it'll say the customer is unhappy. Now, the main objective of the application is not to check whether the credit card is valid or not. Okay, it's for checking whether the customer is happy or not happy. But I'm going to misuse the functionality of the application, okay, to use this. Okay, now every time I'm going to use this functionality for a customer, the organization which owns this emotional detection application is going to make a payment. Okay, make a payment to the provider. Okay, so that means I'm using somebody else's capability and making him to make the payment to see whether the credit card is valid or not. Okay, this is called the adversarial reprogramming attack. Now the model is going to fall onto this trap even without it realizing that it was developed for emotional detection, but is now detecting an valid or invalid credit card. Okay. Problem emotion detector. Okay, hacker creates special mask, a pattern of colorful statistic noise. Again, the QR code need not be a QR code; it could be a border. But the objective is to convey the message, okay, to the emotional detection application. Generic photo of neutral phase, encode the credit card data into it, a static noise mask. Upload this weird fuzzy photo to the website. AI looks at the photo, does not know it's looking at the credit card data hidden the static. It processes the pixel, the valid card, static triggers the neurons for a smile. Okay, the AI outputs happy. If it's not a valid card, then it's unhappy. Okay. So that means the adversarial reprogramming will ensure that the adversary is fooling the credit card application to do some other activity, not what it is intended for. Model poisoning attack. Okay, the model poisoning attack is something which can happen, which happens at the learning phase. If I'm going to input a lot of junk data as a part of the data set, okay, it makes the model useless. Okay, there is an availability attack. Okay, if I'm going to put in incorrect data, okay, it becomes an integrity problem. Okay, with the poisoning of the data set during the learning phase, I can make the model useless, which is availability attack. And I can also make the model as something which you cannot trust. It's the integrity part. Okay, break the system, secret backdoor, integrity attack. Okay, so it's a model poisoning. So the impact is increased latency, financial drain. Okay, if you're going to have it on the cloud, okay, the excessive denial of ML services is going to consume a lot of energy and the CPU. Okay, so your billing will increase. Okay, the battery exhaustion, okay, energy consumption, increased latency. The response that you're actually going to have for a query is going to be lesser. Okay, comparatively. Okay. Strategies include validating and filtering the user input, so you can have a secure API gateway, okay, using which you can control the input that's been given to the AI application. That is number one. Continuous monitoring of the resource consumption, restricting the input size is also very important. Okay, and like the example that we actually saw for the barista, you can have a long input given. Okay, if it's a long input, you can say that we cannot accept such a long input and keep your input short. So that will also prevent the hackers or any of the adversary, okay, from prompt injection or getting onto this denial of machine learning services. Additionally, the machine learning can be used to detect the DOS attack by analyzing the network traffic and identifying the anomalies. So on the positive side, it is also done, okay, because it's a learning that's been done, right? So the people, who have joined me for the CSSP, we discussed about the anomaly-based intrusion detection prevention system. You'll be subjecting the ideas for close to around a month to 3 months for learning period. That's what the ML is going to do. So you're also subjecting here for learning period, and it learns. That also it learns. There's a rules that is actually formed, okay, for the DOS, DDoS attack, etc. Or you can learn using the SNOT signatures that is available for free download if you're going to go for the AI-based systems, okay? And that's all on us. So the Subramaniam, these are the trainings we are delivering, okay, on the AI security officer, AI-based data protection officer, AI officer, governance risk officer, 42,000 lead implementer with 21502 as a dual certification, and lead auditor with 19011 as a dual certification. So if you want any of these trainings, you can write to us on training@itriples.org.uk. Thank you very much and wish you a wonderful evening. Cheers.